Okay, so today we'll discuss the performance tuning. Okay, so I already told regarding so how we can verify the performance tuning. So this is the common thing. Okay, so which we need to verify in everywhere, even though it is the any kind of RDBMS technology. These are all the common things. Okay, so let's discuss SQL Server performance tuning, how we can do. Okay, so we need to identify some couple of things. The first one, high CPU utilization. Okay, if applications team is asking, application team means who is using that application. Okay, so we are facing slowness issue, kindly check from DB side. So if they are asking and they raise the change, they raise the incident request, or they send the mail. So as a DBA, so what we can identify? So first we can identify the high CPU utilization or high memory utilization is there in the server or not. Just go to the task manager. Okay. So just go open the task manager, go to the task bar and open the task manager. So it will display the task manager. So how the CPU utilization and how the memory utilization. So if you see here, okay. So if you go to the performance, so here it will show some kind of information, right? So how much CPU is utilizing your processes? How much memory is utilizing your process? Okay. So this is the way, the basic fundamental health check. So if any CPU high utilization or memory high utilization, you simply open the task manager and where it is consuming what percentage. Okay, it is consuming more than 90% or 85%, you will get the threshold values, you will get the alerts. So we are configuring the alerts based on the threshold value. Okay, so when coming to the DB side, so how you can verify? Just you can run it. You can run sp underscore who to command. Who are all logging into your mission? Okay, who are all logging into server, and what is the command or what is the query or what is the process which is going on. So we can identify from this. So when anything is running, so here the CPU time is the column, and okay, so here we can identify, so what is the process which is running by whom, from which IP address or which computer name or which login is using. So everything, so we can able to see here. Okay, so this background processes, sleeping process, we don't want, because so that we should not any impact on that. So what we can do, so we can identify the here. Okay, what is the running or runnable process, what it is and how it is using. Okay, so in this way we can identify where it is the CPU utilization is more, and then we can identify those process. We can identify the particular login, who is login, their login name is coming here. Okay, and which address, which host name, so what is the host name it is coming. So everything we can able to see here. We can easily track with that person. and we can identify that session details and we can inform to the application team. So and so process is running, so and so session ID, so and so time. This is the CPU utilization. He is running this query. Then we can share all the details to the application team. We can based on their response, then we can take the appropriate action on this. So they will reduce the process utilization. Okay, maybe they are uploading the bulk insert or maybe any kind of report generation. If CPU utilization is high, memory utilization high, they will go by some step by step. Instead of inserting millions and trillions records at a time, they are inserting some chunk. They are bifurcating some partition, some chunk wise. They will insert like that. Based on the whatever they are performing, they will analyze. They will come to us. So we'll reduce the process. So this is the way we can identify the high CPU and memory utilization. Okay. The next one, LRQ means long running queries. So this long running queries also, when we log into the system, when we log into the server, so you can find the query, select star from sys.sys process. So when you run this command, it will show all the running processes. Okay. So how long it is running also, here it is showing the login time and last batch when it was run. So this login time, so what it is the time and how much it is running, from how long it is running. Okay, so here we can see the last login time. Okay, and we can identify how long it is running. Okay, so we can identify that particular process which is consuming a long time. Okay, so we can identify those processes and we can inform to the application team. These are all the queries is running from the long time. So we have some couple of scripts so we can easy to identify. So I will share you those scripts. If you run those scripts, so you will get only that particular kind of things only. Okay, so you are getting only the login details, login session ID things. Okay, just a minute. Okay, so in this way we can identify the long running queries, how long it is running. We can see the start time and the end time and how long it is running. Also there will be a column, so we can easily fetch out how many minutes, how many hours it is running. So we can easily identify, so what is the long running query session details. Okay, so that we can easily identify. So here in the local in my machine nothing is there. Okay, so if it is running the long running queries means running last 1 hour, 2 hours, 3 hours, 4 hours, or 10 hours, or last 24 hours. If you schedule a job, it is running from 2 days, 3 days. These kind of things is happen. So at that time, the application team has identified. Okay, so we are getting some kind of slowness issue. What are the long running queries running? Please share us. Then we need to identify that particular session details and we can give it to the details. Okay, so that is about the long running query. Next, blocking details means if any one process is blocking with some other process. Okay, so for example, you take one table, you are updating. Okay, and you are inserting on the same table. So first whoever is acquiring the log, so they will get the resource. Okay, I will show you once again. See, for example, use AdventureWorks database I am using. Okay, if you don't know this also, don't worry. Just you go to the here and you can simply select the database, whatever you want. So please go through that recording videos, whichever that people recently came. Okay. So simply select, take any table, select star from just a minute. If any table is there, otherwise I have a sample database. Let's me wait. Okay. So simply you can use the my database DB1. Okay. So, and you can select star from T1 is the table name. Okay. So what I am doing here, I am updating one record. So I am opening the transaction begin tran. This is the explicit transaction. Okay, update. This is the basic query commands. Okay, update insert queries, nothing else. Update table name, set student number equal to 5. So if I run this query, because one record is there, that's what I am not mentioning. So now the query executed, but I open the begin transaction. Transaction is not completed. If you want, you can find the data. It is showing 5, but is not 100% committed. It is still in the buffer only. When I make it commit, then only it will be the committed. So if you want, you can see the transaction details selected at tran count. It is showing transaction count means how many transactions are opened. So now I open the one begin tran. It is showing the count is 1, right? This should be 0 always. If it is showing 1 means somewhere the transactions is not committed. They are using begin tran. This we can call it as a explicit transaction. Okay. So why blocking is coming, I will show you. Now I am opening the again session. So here also I am doing the same thing. Okay. Here also I am updating some record. Here I am updating with student number is 6. If I am executing this, see this never will complete because here already I open the transaction. Here also open the transaction. I am updating the same table. Here updating student number equal to 60. Here updated student number equal to 5. If you see this, okay. So, but in this case, when you see this, you can see the blocking. So there is a blocked by column here. When you go to the blocked by, so it will be always should be the empty. But here it is showing is what 61. Who is 61? 61 is this process ID. When you see the top here, 61 is the session ID. This session ID 67. 67 is blocked by 61 because the first transaction started by 61 session ID. Later 67 started, but the 67 is waiting in the queue because of 61. 61 they have performed the transaction, but they have not committed or they have not rolled back. So this is the waiting for this. These kind of situations is happen in the real time. Same table, multiple users are updating at the same time or inserting anything. So that in the type of situation came, then we are getting the blockings. So in this time, so when application is not responding, it is going into the hang situation. The application team is asking us that please verify the what is the problem in DB set. So what we can identify, we can check the all the things like CPU is normal, memory is normal, long running queries. Definitely, if we have, we can share it. Then if any loggings or blockings, then coming to this situation and we can see this. We can identify any blocked by session. We can identify those session and what it is running. If you want to see, there is a command dbcc input buffer of your session ID. So if 61 what it is running, so here means we know. If in the read time whatever it is running, we should not know. So then we can run this query. Here it is showing. Okay. Just that information we can able to see. So what is the session details and everything. So if you go to here, then it is showing the session ID 61 what it is there. 61 it is using some db1. They are updating, the update command is running. Okay, here is some select command is running. So in this type of situation will come, then the blocking came. So if we want to clean SQL Server, by default, if this kind of situation is happen, they will kill automatically whatever the resources are consuming less, they will give the priority to that. And the long time sessions will kill automatically. That is the different situation. But when you find out the blockings, how we can troubleshoot, this is the way. There is a column in the blocked by, so it should be always empty. If it is there in the any session ID, so here this is the 61, this is the 67. 67 is blocking by 61, so that's why 61 is coming here. So we need to identify those sessions, who is running, what they are running, on what database, from what time it is running. We can get all the details and we can share it to the application team. These are all the blocking details. So then they will take the appropriate action. If they ask us to kill, then we can kill. So there is a simple command, we can use the kill. If I want to use the kill 61, so it will automatically roll back. Okay, so 61 is my process. I can't kill my process itself. So go to the some other session and you can kill it. Kill 61. If I kill it, once I make it kill, then automatically this should be executed successfully. If you see, I am executing. Once it is done, this is completed. So if you want to update, then make it commit, COMMIT. Commit means we are 100%, we are successfully doing the record. Now it is updated perfectly. So if you want to see this, then you can fire the query and you can see it. Now the blocking is cleared. I killed, right? That's why session is closed. Now the 6 is updated. So in this way we can troubleshoot and we can perform the blocking details and locking details. Okay, blocking and locking. Blocked means which is blocking by, then locking means. So there is a command here, log writer, okay, exclusive log, shared log. These are all the locking things. Locking means, so whoever the process first came, they are performing to the operations. The request is goes to that one. That is called read log, write log, shared log. So here the log monitor is there. If you see here, okay, that will be happen by default.
Hello, one minute. Hello.
Yeah, please unmute if someone is muted.
మనకి ఇక్కడ బ్లాక్ అయిందని చెప్పి 61 లో ఎలా తెలుసు సార్?
See here we can able to see, right? If you run this sp_who2 command, okay, yeah, then it is what if it is showing in the blocked by column, whatever the session ID is there, that session ID will come here. So if 67, okay, and some number definitely it should come. That number is nothing but SPID. So somewhere that SPID is also there. That same number is coming here. Based on that, we can identify.
Okay, okay, thank you.
Okay. So deadlock means, so whatever the previously I executed the scenario. Okay. So if I same thing I am done this one. I am started the transaction. Here also I am started the transaction. Okay. So if I never do any commit or rollback, if I keep it like this, it is going into the abnormal situation. It is never committed. It is going creating a deadlock situation. Keep it for a long time, for 5-10 minutes or 20 minutes will be the same situation. So what it will contain? Maybe if someone also again, if some more came and they are also started again some other transaction. See, if this is executing, this is executing, this is not committed or rollback. So in this situation, deadlock will occur. So deadlock means your blocking will be continue for long time if the two processes are using the same resource. Resource means any table or procedure or anything, any SQL object they are using at the same time, but no one, they are not releasing the resources. Both are waiting for the same resource for a long time. The deadlock situation came. If keep it like this, after some period of time, the deadlock will occur. So it will showing as 60 and 59 are using the same process. SQL server unable to find out which one is going to be continued. This is the deadlock situation. So what SQL server do? Whichever is executing less time, that will give the first priority. The remaining will be cancelled automatically. This will be happen in the real time. But this is also happening in the production server sometimes. Maybe the users, no one will give the like assurance. Okay, everyone they are hurry burry, they are starting do my work first, do my work first. So in that situation, the SQL server will take care. Whoever taking the less resource means, for example, I am updating 10 records. Someone is updating 20 records. Some other I am updating 100 records. In these three, which one will complete first? 5 records will be completed first. So automatically the SQL server will give the first priority to the 5 records. The remaining 2 will be cancelled automatically. So this is the deadlock avoidance situation. So here, because of what purpose it is coming, so we have a 2 trace flags. Okay, so we can enable those trace flags and we can identify the deadlocks. Okay, so I'm canceling this. I'm rollback means just rollback. Otherwise, I'll make the commit. First, I'll do this. When I do this, this is ready. Now this I am committing. Now this is ready. Here I am rollbacking. Rollback means that is not done. Going to the original previous state. Okay, so that is the situation we can perform the blocking, locking, and deadlock details. Okay. The next one, query execution plan. How we can identify the query execution plan means if you get any kind of query, right? So you can take that query and we need to estimate the execution plan. Okay. See, for example, if this query is there, I have some query. So if I want to estimate this query, so select that query. Okay, select that particular query. And you can, here there is a column called display estimated execution plan. Just select this execution plan. It is showing like this. So this is the estimation execution plan. This execution plan, it is showing like this only. Here so many components are involved. So this is the very big important thing. Every database administrator or DB, whoever is using, they need to a first step. If the performance point of view, if any query is running slow or if anything is running slow, you have the inline query or any procedure or any query, what you need to do, the first you need to estimate the execution plan. When you estimate the execution plan, it will show all the details. What is your query and what operators are involved, what are the components, how many tables are there, what is the scan position. Here there are the different scan positions are there: table scan, index scan, seek scan. Okay, table scan means that is the default scan. Okay, table scan will be the large time taking scan, just like a record by record. If you have 1,000 records, it is, if you are fetching, if you have 1 to 1,000 numbers are there, if you are fetching I want 500 record, so what table scan will do, it will use the one by one, take the first record not matching, go to the second not matching, go to the third, like that. It will perform 500 number of iterations. It will take a lot of time. So that is the worst scanning. Okay, so we should never give the scan should be table scan, so we need to change in that one. Okay, so the next one, index scan or seek scan. These two are the best scans. Okay, index scan means, so based on the index, the data will be sorting accordingly and they will be filtered out very fast. Okay, when indexes came, I will tell you in details about that. So there are two types of indexes: clustered index and non-clustered index. Clustered index, we can able to create only one for a table. The primary key is mandatory when you want to create the clustered index. When we have a primary key on the table, automatically clustered index is created. Non-clustered indexes, we can create a number of non-clustered indexes based on our requirement. Okay, I will show you what is the syntax and how will be created. It is very simple. Okay, so what we can identify here. So here all the scans should be a index scan or seek scan, that should be taken care. Okay, it should not be the table scan. If any missing indexes are there, it will be showing in the blue color. So you need to identify according to the missing indexes, we can able to create it. Otherwise, we have some standard script is there. We have a select queries. So we can run that select queries. You can easily find out the missing indexes. I will share you all those things. Nothing. It's a very simple select query. If you want to find out the missing indexes on a tables for one table, we have a script. If you want to find out all the indexes on one database, we have another script. So it's a select queries. We can simply execute that query. It will show all the indexes and columns. Based on that, we can able to create. Okay. So, but what we can identify here in the estimated execution plan, here it will show the cost. Here cost, there if you see here, the down is the cost 0%, 0%, 20%, 30%, 6%, 7%, like this. So if the cost is very important, your cost should not be 90 or 100% or 80%. Whatever the cost value should be as much as less. If it is all less than 10, it is well and good. If all less than 20 is well and good. It should not be 60, 70. It should not be like that. Okay. If cost is more, then your queries will be taking more time. But which cost we need to identify? The table value things cost should be very less. This hash match aggregate functions, this is okay, somewhat fine. But this is also not good. The basically what we need to consider here, the cost value should be less than 10 or 20. It between that less than 0 to 20. It should not more than that. If you make it like that, your query is very efficient and excellent query. It should be taking less time. It will be the very fast. If here it is a 90%, 80%, 60, 70, each and every operator, if you see here 0, very good. Here 0, here 0, here 7, here 7. And if you go to the second row, it is 0. Now sorting is 21. Now hash map is 73. So here only hash mapping and sorting only some value. The remaining all are very less. Okay, so in the normal ways, we need to identify the each and every cost operator. We need to better how much we can able to reduce. We can reduce. That is there is no any fixed solution for that. Based on the experience and practice only, you will get to know you have to do some kind of all different combinations. Which one is taking less, then we can finalize that index. For example, if you have 3 columns, you created the index on 2 columns, you may get 20%, let's assume. Again, you can change the indexes. You can create the index on 1 column, maybe the cost will be 30. If you create the index on 3 columns, maybe your cost will be 5. So in these 3 combinations, which one is best? The 5 is there, that is the best. So like that, we need to analyze and estimate. So by practice, you will get it. Don't worry, this is not a so much complicated thing. It is very simple. The same query, we are changing the columns and we can get the different values. Based on the execution, estimation, execution, we can finalize the which one is the best execution plan. So we can fix that issue. So this is the basic thing of estimate the execution plan. So here we need to the overall query one. So if I executed 2 queries, one is the one query is the 5% cost. This is the very good. The second query cost is 95%. This is not good. Okay, so I need to reduce this cards. This value should be less than 10, or it may be less than 20. It should not more than that. So 95% means this query performance is worst. See, because at present my database nothing is there, no data. That's why it is coming fast. In the real-time production server, the TBs of data is there. So many lakhs of transactions is going on. In that case, if it is run this queries, the cost will be 90%. Means it will take time. Taking time means not taking hours and minutes and no. It is fraction of second only. It will get the lot of difference. For example, if you open the WhatsApp, it is opening after 1 minute. Are you willing to like? No, you won't like. When you download the video, it should be fraction of seconds only. You will like. If it is downloading after 1 hour, you are not liking. You said that this is the bad feature. Internet is very slow. This is network is very slow. Geo is fast. Like that, how we are thinking the same way. The application, if the one query is completing in 2 seconds, one query is 10 seconds, we feel that only the seconds, no problem. But when coming to the real time point of view, that seconds also very important. Okay, so this all about the query estimation execution plan. So I think session will be closed in another half minute. So we'll continue tomorrow. Okay. So that's all for today. See, because this performance tuning is the so much of important and so many points we need to cover. So basically, we'll take it some time. Okay. See, if I explain only what is what to, then it will be not good for you in future. That's what I am explaining in detail. Okay.